You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. For over 75 years, Batesville Products has been engineering, casting, machining, inspecting, and polishing aluminum castings for over 70 industries nationwide. In today's episode, we'll continue to share our experience and industry secrets. Casting Class is in session.
Last month, Tim Weber and I discussed the pros and cons of using different casting materials: iron, steel, aluminum, zinc. This month, we're diving deeper into the science behind melting aluminum. So today we're talking about clean metal. So when we melt aluminum, there's additives, we're adding gas, we're removing gas. So Tim, can you kick us off by defining what we mean in the industry when we talk about clean metal?
So basically, clean metal it's not contaminated, it's unadulterated. The alloy comes in, we use A356, it's made up of primarily aluminum, silicon, magnesium, manganese, copper, it's got a little bit of zinc. The alloy, if it's correct and if it's clean, again, it should pour well, it should machine well, you shouldn't have inclusions, you shouldn't have hot spots, and then it should perform as a part out in the field the way the designer or engineer has drawn it up. So it won't have cracks, it won't have fissures in it, and it should have the strength, ductility, those type of things. So that's why clean metal is important.
So what happens if you do have that contamination? What can you do to fix that?
So first of all, you should be testing. For instance, our alloys come in with certifications, and then we send out coupons to an independent lab and have the metal certified. And we do that on a regular basis every week, every furnace. If you find it's out of spec, you need to quarantine those parts that have already been poured and then determine, does that create an issue? Do we need to scrap those parts? Do we need to get deviation from the customer? That type of thing. What you try to do, though, is maintain a clean furnace. Like I said, we start out with certified material, and then through our processes, we make sure that we have a clean bath.
Yeah. Prevention is the best cure.
Prevention's it. Correct.
So I know there's a lot of talk about primary versus secondary metal. So here we use primary.
We use primary.
Mm-hmm.
So primary comes straight out of the aluminum is made from bauxite, and through a fairly involved, expensive method using a lot of energy. That's how they smelt it, and they come to process the pure aluminum. Secondary is just recycled. However, primary is held to a more strident standard, tighter regulations and quality measures. So that's kind of important, especially, for instance, in the aerospace industry, they specify 100% primary just because of those regulations and those standards.
So dross is a word that you hear thrown around a lot when talking about melting metal. You hear about dross and slag. So from what I understand, these are the impurities that rise to the surface of the melt. So your oxides, your contaminants, they float on top of the surface of the furnace. So how does that play into the clean metal?
Well, dross isn't necessarily bad. Think of dross as a lid on your furnace. That is the top layer that separates the molten bath from the atmosphere. Managing dross is critical. Okay, so you manage it, you just don't want to get it mixed into the bath.
Yeah, you'll see our operators, they're scraping the top and getting the metal underneath, and that's
exactly
what they're
right.
using.
Yep. There's dross versus slag. When we flux, and flux is a cleaning agent, typically there's salts that you immerse into the bath and draws out the impurities and brings them to the surface. And at that point, you take that material and you clean that off.
You scrape off the top.
You scrape it off.
You don't want that in there.
You don't want it in that bath. One of the problems with aluminum is aluminum oxide is the same density as aluminum, the good alloy, so it'll float around sometimes in your bath. Unlike like irons and steels, the impurities come to the surface and they have a different density, so they organically just float up. In our process, and in aluminum melts, you have to control that a little bit better.
Didn't you say the other day aluminum oxides as soon as it hits the air?
Yeah.
It's crazy.
If you go through this and you think, how do we ever make an aluminum casting? Man, it's just tough.
Yeah.
There's so many things that affects it. The cleanliness, that's one thing. That's one part of the whole the equation. So, but again, it's not necessarily eliminating it; it's controlling it, and something you got to maintain, and it has to be a regular part of your maintenance schedule.
So one thing we do a lot of is controlling the gas level, because that's really important to our customers.
It's a big deal. So basically, we're talking about hydrogen, and hydrogen isn't a bad thing. You need hydrogen in your mix. Hydrogen is formed with water when it actually touches and engages with molten aluminum, and I'm talking atmospheric moisture. I'm not talking about actually a wet ingot going into a
You don't
melt.
want that.
That'd be terrible. But we're talking about the atmospheric mixture. It's organic. It just happens. So you need a certain amount of hydrogen in a casting, no matter what. You can't run a casting with zero hydrogen because as it cools, you get cracks in your casting because the casting starts tearing itself apart as it cools and shrinks. So controlling the hydrogen is critical. Again, that's one of those things that you have to test for it, and then you have to maintain it. You've got to be aware of what's going on outside. First of all, what we do, and a lot of melts do, is they isolate the bath from the atmosphere through just controlling the dross, and actually lids on top of the furnaces.
Yeah, the atmosphere plays a big part in casting, and you wouldn't think of that until you actually get down into the science.
Yeah, and that's what you talk to the old foundry guys. They always talk about the barometer for casting aluminum. What's the atmospheric pressure? Oh, by the way, at the same time that's good for fishing. So they look at the atmospheric pressure, which is just the weight of the air. And so in water, you can imagine that's going to affect the activity of the fish. If it's going up or down, they're more active. If it's sedentary, if it's at a level point, they become less active. So, and in aluminum casting, again, it's a bath. It's liquid, so it has the same tendencies it would have on a body of water like that. So one of those things you just have to be aware of. And today, with the sophistication of equipment and with the history that we've got, it's not so much tribal knowledge, it's actually science. Okay,
Yeah.
Let's measure the gas. Do we put in hydrogen or do we pump in nitrogen, which precipitates out hydrogen, and just maintaining the proper level.
Yeah, so back in the day, it was more of an art.
Very much an art.
You just know, oh, good day for fishing, it's
Yep.
a good day for casting, whereas now we have the science behind it.
In summertime, when you're in greater Cincinnati, it's humid. So there's a moisture content is higher in the summertime rather than the rest of the year. So you have to be aware of that, and you have to be more diligent in maintaining your hydrogen.
So back in the day, they had unique ways of removing gas or adding gas. So what did they do back then, and what do we do now?
So removing gas back in the day, so what you're trying to do is put something into there that will attach itself, that the hydrogen will attach itself to the other gas and bubble up and come to the surface. And back in the day, and still done, and it works readily, is nitrogen, pump nitrogen in, and which we do today. Works rather well. Nitrogen has an affinity for attaching itself to hydrogen and coming to the surface. So that's been done for a long time. One of the things that we do now is put hydrogen back in, and one of the ways they used to put hydrogen back in was to actually put a log into the melt. And they would use, the best wood was cherry wood, and they would stick it into the melt and bubble it up and raise the gas level. It's still very effective. It's not as scientific. You can't control it, but you can put it back in and test it. And then if you need to, you can actually regulate, take a little bit of hydrogen out if you put too much in. But it still works. Kind of crude, but they still work. So
now we have a fancy automatic degassing machine, so you see all of the levels. If you watch it, it goes down in, it's spinning around for, 5 minutes.
Blends it up.
And you just watch everything come to the surface, and it will tell you exactly what the temperature is, the levels of everything that's putting in, the flux.
It's really sophisticated. Some of the new equipment now, it's all computer controlled and, pre-programmed, and you can have a program for each part now. You can schedule per the parts that have similar gas levels and similar makeups. Pretty cool. And the other thing it does is it mixes in some of the additives. So one of the things that we do is, you tend to burn out magnesium, which is important. So we add back in magnesium. We put Tibor in, which actually helps with a lot of things. It actually helps with the actual pouring and actually gives you a little bit better part for secondaries as far as machining. But you've got to mix that Tibor in. You can't just throw it in. It'll sink to the bottom, and that's what it'll lay. So when we go through our process, it not only is taking stuff out, but it's mixing some of the additives that we add in at a correct amount.
One thing you started to mention was the gas level requirements. It's different depending on the part that you're casting.
It's very different.
You can't use the same pot for every single part. You need to make sure you're scheduling it because each part's custom. They have different end uses, industries. Everyone needs a specific gas level to get the correct part out at the end.
It's a good point because too much hydrogen will make your part porous. So if it's a pressure tight vessel, you definitely have to control that. So you tend to run it at the lower end. On the other hand, there are parts that will not fill out, that will not solidify unless they've got a little bit more hydrogen. So exactly right.
Do other foundries like sand casting, die casting, is this kind of balancing of the gas level and measuring it, is this as important for them, or is it like a different process for those kinds of foundries?
It's as important. It's shocking to me that even to this day, a lot of foundries don't do that. The way we do it is pretty black and white. It's pretty whiz-bang. We've been doing it for years. It's called the RAS test, where you take a coupon of molten aluminum, depressurize it, and you weigh that coupon in water and out of water, and that'll give you the specific weight of that particular coupon. Then we have a scale. It's a scale from 1 to 10 of what percentage of hydrogen is allowable. A lot of foundries used to just do the coupon. They'd cut it in half and they would visually inspect it, which is pretty close. That works to an extent, but again, it's a little bit subjective. I might say that's a 3 and you might say that's a 5, and who's right? But you put it in water, you actually measure it. Now you've got a specific number, a specific weight. So that's a little bit tighter tolerance. But we've had foundries in here recently that they've never checked for gas, and they know it's important, and they do some whiz-bang parts and some pretty sophisticated stuff, realizing that they're probably fighting a problem that they could fix pretty easily.
We talked about how nitrogen and hydrogen levels can affect casting, also the atmosphere, talking about your humidity. Temperature is another one that can affect it. So can you talk a little bit about the temperature of the metal and the mold and the furnace?
That's a good point. So the metal temperature, again, is one of those things that we pre-program when we do our solidification models. For number one, getting the metal in to the cavity and getting the oxygen, getting the air out of the cavity so you can fill it. And so you don't have the mixture of the aluminum and the air, or where you have pockets that are just not filling for whatever reason. But then you have the other side, which is the cooling part of it. You still have to get that part to cool. Again, one more little element that raises its head when you're trying to figure out how to get aluminum parts.
There's that ideal range to be in, and if you're even a little bit outside of it, you're just wasting your resources.
Absolutely right.
So I think overall a big lesson for engineers or for everyone listening, it's important to recognize that you can't just melt aluminum and pour it into a mold and expect a perfect casting every time. So it's balancing that pot temperature, the gas level. It may be perfect for one part, but it might not work for the other. It might not work for that industry. So it all goes back to how every part's custom. There's no one size fits all answer.
That's exactly right. The thing you want to make sure that those things are monitored. Those variables are looked at and measured. Once you measure it, you need to record it and make a history, and then you start getting your graphs or measuring it on point. All important. So you get your heat, you got your clean metal, you got your gas levels, and then you just got your production times. How long does it take to pour this casting? How long does it take to set up? So those things, if you get them all working, you get good parts.
Mm-hmm. And from the customer's perspective, you're looking at suppliers. Your custom part, it deserves that custom attention to detail.
Those are good questions to ask up front also.
Mm-hmm.
Are these things you monitor? You don't need to necessarily, the customer doesn't necessarily need to know or want to know the formula, but they want to know that you know how to maintain that formula.
Yeah, make sure they know what they're doing.
Right, exactly.
Do you have any last thoughts or any other science to dive into?
It's just now that I think with the technology that is out there, I think the power of hydrogen and aluminum, I think that is an important modifier. And I think we're going to become more and more sophisticated in that relationship between those two. The hydrogen plays a huge part, and it's got some unique chemical properties that interact with the molten aluminum. So I think as we move down the road, some of these modifiers, especially hydrogen, putting it in, or dehydrogenization, is going to become a bigger and bigger factor and play a more important role in the design of castings and the production of castings.
You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. Be on the lookout for our next casting class on the first Wednesday of every month. Until then, you can find more resources like videos, written guides, and case studies on our website, batesvilleproducts.com. That's batesvilleproducts.com. See you next month.